Okay, another great day for formal methods. This is funny because this is take 2 and everybody's had to suffer through this intro before. Anyway, this one we won't cut. So today we're going to do split off term. All right. Shall we do it take 3? No, let's just go on. So this is getting to be more of a production than is necessary. So today we're going to do split off term, which is the last topic in chapter 8. So let's see what split off term is all about. Okay, so let's take a look at the theorem. Now this is a theorem, it's not an axiom, notice. It's a theorem. So we can prove it. As a matter of fact, we will prove it. You will help me prove it right now. Okay? But let's take a look before we do it, before we prove 8.23, let's take a look at what it says. So look at 8.23a on the left-hand side of the equals. It says star over I, range 0 less than or equal to I, less than n plus 1 body p, right? Now I ask you, what are the values of I in the range? What's the first one?
0.
0, so it goes, the possible values of I are 0, 1, 2, etc. all the way up to, now let me ask you a question, what is the last one?
N.
It's n. Now why isn't it n? It says n plus 1. Why isn't it n plus 1?
Less than n.
Because it says less than n plus 1. So everybody understands that whenever you have a range like this, you can. It's always easy to identify what the last term, what the last value of I is. Are you with me? Now if that were 0 less than or equal to I less than or equal to n plus 1, then the last term would be n plus 1. Is everybody, that's easy, right? Everybody knows how to note that. Okay, so now what does split off term say? It says that that is equal to, now let's take a look at the right hand side. We have that exact same quantification, except now it's star over I, range 0 less than or equal to I less than n. So tell me, what is the last term of that one? That's n minus 1. Are you with me? So there's one less, actually what happened was the quantification on the left has one more term than the quantification on the right. Are you with me? So, but what else do we have on the right? Star what?
I replaced by n.
P, well, star P with I replaced by n. Now, what was this? Now, where did this n come from? Where did this n come from?
That was like, it's kind of,
It's
like you're expanding but just one term.
Yeah, it's splitting it off. Yeah.
B is like splitting off the first term.
Yes, and B is, part B is the exact same kind of thing, but here the value of I started, what were the values of I here? 0, 1, 2, 0, 1, 2, 3, 4, all the way up to what? N. And now what about this range? 1, 2, 3, 4, all the way up to n. So what's missing here? The first term, right? But what is the first term? It's P. So you can split off from either end.
You can multiple terms too. You do like split off.
Well, we don't have. Yeah, you could split off. Yeah, you could split off term from. Yeah, we will never need to do that. All of the manipulations that we will ever need will be splitting off either from the first part or the left part, right?
Probably update it. They shouldn't have it go from 0. They should probably have it go from A. Make it more generalized.
True.
What?
Instead of start at 0, have it start at A. Have it more generalized than 0.
Oh yeah. Oh, I see. Right. Yeah. So we could go. Yeah, we could have gone from N to M. Yeah.
Or A to N.
But yeah. But you know, usually in computer science, whenever you start counting at 0. That's really pretty standard. Like in the C++ programming language, or Java, whenever you have an array, the arrays always start at 0. You know. So I mean, this is kind of a reflection of that philosophy. Okay. So, are we ready to prove 8.23a? Okay, so here we go. 8.23 A. Split off term proof. Okay. Now what we're going to do is we're going to start with the left-hand side and we're going to get it to equal the right-hand side. Okay. So the left-hand side is star I, range 0 less than or equal to I less than n plus 1, body P. Okay. Now this equals by the following mathematical fact. Do you believe this? What is 0 less than or equal to I less than n plus 1? What does that equivalent? This is a Boolean expression, right? It's either true or false, yeah? So you see we use equivalence because equivalence works for what? Booleans, okay? So what's another way to write 0? Actually, what is the conjunctive meaning of this? 0. What's the conjunctive meaning of this?
0
Is this equal to I and I is less than n plus 1. What's another way of writing this? Do you buy this? This equivalence 0 is less than or equal to I is less than n. Now, but I'm not finished yet. Because what did I leave off here? N plus 1. So this equivalence this what? Oh.
Just write it. I don't know.
Yeah, I'll just write it and see if you believe it. Or what? This is 0 is less than or equal to I less than n plus 1. That's the same thing as 0 less than or equal to I less than n. Or
0 less than or equal to I less than n plus 1.
no.
Oh, I is less than n plus 1?
No. Oh shoot! I was hoping you could anticipate this. Oh, what about n?
We have to add in somewhere.
Yeah. Or what? But it's a Boolean expression. So or what? No. Or I. Yes, or I equals n. Do you buy this?
Yeah, I got it.
Do you buy this?
There were like 4 different ways you could have written it. So.
Yeah, let's write it another way.
No. We're going to write it this way. Now, okay. It appears as if we have some doubters. So guess what? This, I'm just going to.
So because of that,
These proofs are not due.
Well, okay. To make you believe this, guess what you're going to do on the next homework assignment? You're going to prove this in detail. Actually, I even have a little handout for you. Here it is. Supplementary exercise S.2.
so if we believe that, we don't have to do the homework?
No, you have to prove to yourself that it's in fact the case. All right. I'm going to actually have you prove this in detail for the next homework assignment. And here is a worksheet for you, and I even give you the hints. So all you got to do is fill in the steps. But let's think about why this is true. Let's think about why this is true. I mean, do you guys not believe this?
I believe it.
Because look, what are the possible values of I here?
Split off last time.
Yeah, that's basically what we're doing. I mean, this is the possible values of I here are 0, 1, 2, 3, 4, 5, all the way up to n, right? Well, the possible values of here are, when is this true? Look, this is a Boolean expression, right? When is it true? It's true when I is what? 0, 1, 2, 3, and it's true when I is n. Are you with me? Now, when is this whole thing true? Well, it's true when I is 0, 1, 2, 3 because true or anything is true, right? Are you with me? So it's true when I is 0, 1, 2, 3, up to n minus 1. But then when I is n, this is true, but this part's not, but true or this is still true, right? So this Boolean expression is true exactly if and only if this is true. Does that make sense? Do you believe me?
Can't the or part, can't both of them be true at the same time? I know, I guess.
Well, even if they were, it wouldn't make any, they can't in this case. They can't both, this and this can't both be true at the same time. But even if they could be both true at the same time, this or still, I mean, this is still, either way. All right? Now, does everybody buy this step now? Okay. So this equals, okay, so who wants to go next? This is very easy. This one's very easy. Who wants to go first? Who wants to take the first easy step? And we'll go from there. Come on, this is substituting equals for equals. Who wants to go first? Come on.
I get the next.
Okay, good, Michelle. Okay, so star I, what?
Range 0 less or greater than or equal to
Yeah, less than or equal to I,
greater than n.
less than,
Okay.
less than,
Or I
yeah, less than n, or I equals n, body, we say body, body P. Okay.
We're trying to prove split off term by using split off term.
No. Well, the split off term is based on this, but if you want to, if you wanted to, all the steps in this little thing that I'm giving you, you would do that all inside there, you know. So
Based on that.
this is a lemma. This is a lemma. Do you guys know what a lemma is? Have you ever heard the word lemma? Or have we used lemmas in here before?
No.
We will occasionally. Okay, so, yeah.
It's not like when you say they hint is math.
A lemma is a small proof used to prove another proof. Okay, so it's a small proof used in another proof. So that's called a lemma. Okay, so this is our first example of a lemma. So you're going to prove the lemma. Okay, and then after you prove the lemma, then you can do this as if it was a theorem. I mean, because you will have proved it, right? So you can accept it now, but if you want to all the gory details, then it's possible to prove that. Okay.
We should use 8.16.
Aha! 8.16.
And then 1 point rule.
8.16 says, oh, look at this. What a great insight.
2 more steps.
What a great insight. 8.16 says axiom range split. Okay, so
R is false, which is
range split 8.16. Good call. Okay, so now what does range split say? Range split says
That's I equals 1, or n.
I equals n. Yeah. Okay, so range split says
We can just take.
or, right?
Yeah.
And then do the provisos hold?
Yep. R and S is false.
Well, but not only that, P is Boolean, right? Oh no, we don't know P is Boolean. But anyway, R and S are finite. Yeah, these are finite. Okay. Oh, sorry. 8.6, I was looking at 17. 8.16 is provided R and S equivals false. So the thing of it is that this and this equivals false, right? Are we good? There. Because they don't overlap, yeah? There's no common, yeah. Yeah, exactly. This and, cannot both be true at the same time. So the range splits, that's using that proviso, good deal. Okay, so tell me, Josh, then, since you came up with this. Star I.
Range 0 less than or equal to 1 less than
I less than n.
Body P.
Body P
Star.
star
Star I.
star I over arrange
Range
I equals n body P.
We should use 1-point rule.
Oh, you're just leading us all through here, so great.
And then we're done.
And then 1-point rule, because, yeah, right, now here's something else, you guys. Anytime you see an equals in the range,
Listen, I.
then,
I'm the dummy. The second one.
Yeah, star I.
Dummy of the second one.
oh, star I. Yeah, yeah.
Star.
There are no dummies in the second one.
Okay, so here's the thing. Anytime you see an equals in the range, ding, that brings up a light in your head. 1-point rule, because that's 1 point. Yeah? So this equals by 1-point rule. Which is 8.14. Boom. And then, what is it? So what does...
It's the right side of what we're proving.
Yeah, so it's star I, 0 less than or equal to I, less than n, p, star,
With I replaced by N. Boom, boom.
boom,
We're done.
we're done. And so guess what you will do for me for the homework next time, besides doing that little lemma? You will prove for me 8.23b.
It's so easy.
But it's, yeah, it's,
Why even like assign it? No.
just so that you will do it, just so that,
Dream robot.
just to get experience in doing these things, all right?
I will do it.
I will eat my hat. If I do it, then I will eat my hat. Yeah,
No. If I do not eat my homework.
good. I will eat my homework. My dog will eat my homework or I will eat my hat if my dog will prove the 8.23b, whatever. Okay, but now so now you guys, here's one other thing. There's lots of different variations on this. Actually, there's an 8.23, A, B, C, D, E, F, G, H, I, J. There's a ton of different ones that we could do, but we're not going to bother. Because what I'm saying is what if this were 0 less than I, and we wanted to split, or here, what if this were 0 less than I and we wanted to split off the left term? You wouldn't be splitting off I equals 0. You would be splitting off what? I equals 1. You see what I'm saying? So no matter where you start, you just have to identify what the last one is and split that off, and then make this other one.
Can you split off middle terms?
No, well, we don't have a theorem for that. That's not useful for us. That you could, but I mean that's just not useful for us. But this splitting off from one side or the other is going to be very useful. We'll use this all the time. Okay, so now. So here's an exercise then. Okay, so Mason, what do you think? For this one, let's split this off on the right. Now, what does this say? It says sum on that sigma is addition, right? So sum on I, 0 less than or equal to I, less than n plus 1, body b sub I. So can you write down what the using split off term, what would this be if we split off on the right? What would it be?
Split off on the right.
Yeah, can you see? That would be
Would this be
sum
sum I
on I, range what?
from 0 is less than or equal to I
Is less than n, very good. Body what? B sub I, right, okay. And then what? Now what's the operation?
Sum.
So what's the, so it'd be plus what?
Plus
Shh.
B sub I.
Up.
Or
Simplify.
simplify it?
Oh yeah, go ahead and do, I see what you're doing. Yeah, do the textual substitution all in your head. I mean, can you do that? It would be B sub I with I replaced by what?
By n.
Yeah, so what would it be? So it'd be B sub n. Okay, so yeah. Does everybody see how that worked?
Yeah.
Yeah, this is the kind of thing that you're going to have to be able to do whenever we do some, you're going to need to be able to do this a lot later when we do proof by mathematical induction. This is going to be a big skill, a necessary skill for you to have. Does everybody see how that worked? Notice here that it's n, it's the, this term was included here, but now we split it off, so now this is less than n instead of less than n plus 1. Because the last one there was what? On the left-hand side, the last one was I was what? I was n, yeah. So that was adding b sub n was the last thing that was being added. So here we split it off, okay? Okay, so Cale, what do you think? This product over I, this time let's split off on the left-hand side. So what we have here is the product over I, 0 less than or equal to I less than n plus 1, body b sub I. So the pi means, what's the operation for pi, remember? That's multiply. Okay, so now let's split off on the left. Let's split this off on the left. So what's the first term there?
Okay, so it's product over I range 0 less than.
Yeah, let's write the individual term that got split off on the left.
So then it'd just be b sub I or b sub n times.
Not quite.
Split off on
B sub. What's what? Hold on.
Oh, b sub 0.
Ah, B. Yeah, you got it.
Yeah.
B sub. Yeah. It's B sub 0, and then what?
Times
Times
product I
product over I.
0 less than I.
Yeah.
Less than n plus 1.
0 less than I, less than n plus 1, b sub I. Because that, is everybody good? Does everybody see how that worked? That's b sub 0 times product over I, 0 less than I, less than n, b sub I. Yeah? So Kyle, what do you think? Aha! For all I, 0 less than or equal to I, less than or equal to n. Let's split this off on the right. B sub I equals 0. So notice that now, do you remember what the operator is for all?
It's either and or.
Yeah, which one is it? Yeah, you're right. It's either and or. Which one is it?
And.
It's and.
It's upside down.
Yeah, it's yeah. Well, except upside down is kind of like, looks like or, but it's and, but it's. Oh, A for and. Oh, that's how. Oh, yeah, that's a good way to remember. Okay, so
Splitting off on the right?
let's split off on the, I think this next one is on the right. Yeah, let's split off on the right.
Okay, so for all I, range 0 less than or equal to
I.
less than n,
Less than n,
body b sub,
sub
I
I
equals 0.
equals 0, then what? And
Just b sub n equals 0, right?
yes, and b sub n equals 0. Good. Is everybody good? Does everybody see how that worked? Okay. All right, Ashley, how about splitting this one off on the left?
Okay, it's going to be 5 squared times
Yes.
pi, or say pi.
Yeah, product over, yeah, the way we say that is product over I.
Product over
I, range,
5 is less than
I,
less than or equal to
10, body,
I
I squared, yes, very good. Okay? Are we good? Does everybody see how to do these? Okay, so now later on, you have some exercises to do some of these, and later on, it'll be, this skill will come in handy when it comes time to do some proving. Okay, you're not going to believe this, but we're going to be able to actually leave early today.
Yes!
Okay, now, but there's one more thing that we want to do, we want to look at before we close, and that is here the following. Now tell me, what are the possible values of I in part A in this slide?
2 and 15.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So from 2 through 15, including the 2 and the 15, right? Now what are the possible values of I in part B?
2 through 15.
2 through 15. What are the possible values of I for part C?
2 through 15.
And what are the possible values of I for part D?
2 through 15.
Oh my goodness.
So look, you guys, we have 4 different ways
Are those the only 4 ways?
to say the same thing. Well, with combinations of less than and less than or equal to, right? Because there's 2 ways to do less than or equal to. There's 2. Oh yeah, actually there's even more than that. You're right, because we could do +1, minus, yeah. So there's a ton of different ways to do all of these things. Now
Yes.
but now here our author gives some reasons why one of these is to be preferred over the 3 other ones. Have you noticed that we've been using a style, that the style that
We've been using that.
We like B.
yeah, we've been using,
Why?
you picked up on that. We've noticed B, yeah. Here's why B is preferred. So here, the point is, B is the preferred style. Actually, I should say is usually, because there are occasions where it's not, is usually. Here's why. Suppose you have this. Suppose you have K less than or equal to, or no, let's use N and M. Suppose you have N less than or equal to I less than M. Suppose you have N less than or equal to I less than M. My question is, how many values are there? How many
M minus N.
yeah, M, there are, yeah, see, there are
Makes sense.
M minus N. There are M minus N values. But if you do it like this, N less than or equal to I less than or equal to M,
N minus N.
yeah. So this is, this is kind of a handy thing to do, because whenever you're thinking about numbers of values to process in a program, if you're applying this to programming, then this is a nice feature to have. And also it's nice. And also here's the other thing. Whenever you know how arrays start at 0.
Yeah.
So if you have 0 less than or equal to I less than N,
Is it an
then there are n values, right? There are n values, and furthermore, the index of an array usually starts with 0 anyway, so you include where it starts. So in C++ or Java, you would say for I gets 0, I less than n, I gets 0, I less than n, I plus plus. See, and
There's the
this is just very common. This is a very common for loop in C++ or
If you
Java.
use C and D style, you'd have to index from -1 to get to 0.
Yeah. Well, I mean,
Oh, yeah.
it's just that this is just very consistent with programming practice, and so we prefer B. But occasionally, there are occasions. I'll tell you, the other one that is the second most common one that crops up. It's A. It's A, where you want to have the low and the high values of an array be inclusive, right? So B is the most common. A is sometimes possible also. All right? So we have a treat today. We could start reviewing for the test today, but I think we've got Monday and Tuesday next week, and then the exam. So you guys are so good that we are ahead of schedule. We are on track, or actually we're on schedule. Okay?
Get ahead of schedule so we can have another day out.
I think we should get ahead of schedule and take our final early.
Okay, so see you on Monday.